Hi again, this is Terry VanNoy in MathPowerLine.com. Math Class with Terry V, my YouTube channel. And here we are in a video series about working with determinants. Now, in the previous video, we looked at a 3x3 determinant which uses 2x2 determinants as part of its answer, and I went through that whole process. So the video before this, which is called How to Work with Determinants, and that is 3x3 determinants. This is problem set 2, so you can kind of look back and check that process if you realize you're sort of in over your head. But we're going to go ahead and I'm going to assume that you know and you've already done one example with me, and let's go ahead and try this one right here. So take a look, pause the video, and work it out and see if you can get that 3x3 determinant. Alright, well, we'll get the answer of -28. So how do I get that? Well, the focus, remember, is always in this first column. So I'm going to write these numbers down. 5. The middle number changes its sign, so now it becomes a -3. The third term becomes the same sign, so that's just going to be added. Alright, now I'm going to have a determinant multiplied by the first number, 5, a determinant multiplied by the -3 here in the middle, and a determinant multiplied by that 5 at the end. So where do these 2x2 determinants come from? So when I use the 5 right here, notice that that's in the first row, first column. The numbers that are remaining are right here, and that's my first determinant. 0, +1, +3, -3. Next, in this middle group, I'm using the 3, and that is leaving this pair of numbers and this pair of numbers not in the same row or column as the 3 to determine or to make up the next determinant. So we're going to put down 1, -3, 3, -3. And lastly, I have a 5 here represented out in front of this determinant, and that leaves these numbers unused, not in the same column or row, and so I'm going to write that 2x2 matrix here and find its determinant. 1, -3, 0, and 1. Now the next step is to, of course, figure out the determinant, and it's going to be multiplied by each of those constants on the outside. So here I get 0, subtract 3. Here it's going to be a -3, or subtract 3, times the determinant in the middle, which is going to be -3, subtract -9, and notice that that becomes adding 9. So -3 subtract -9, or +9. Got to be careful about those sign changes, don't we? And this last determinant here is going to be 1 times 1 minus 0 times -3, which of course is 0. All right, let's work it out. So that's 5 times -3, -3 times 6, and 5 times 1. And that's going to be a total of -15, -18, and +5. Now let's make sure I did it right. That should be -28. All right, so a 3x3 determinant is made up of 2x2 determinants. All right, a long process, but I hope that this color scheme here kind of helped you out. All right, we're going to move on to Cramer's rule, how determinants are used in systems of equations. Thanks for watching.